Hello everyone, and welcome back to the Fluctus Channel. Jet engines are highly complex machines that demand extensive research and development to enhance their efficiency, performance, and environmental sustainability. Collaborative efforts between companies can significantly improve R&D practices and lead to more effective design solutions. This is exemplified by GE Aviation and Safran, two major engine manufacturers that jointly launched the revolutionary Innovation for Sustainable Engines RISE program. This partnership focuses on developing cutting-edge technologies for the next generation of single-aisle jet engines. The RISE Revolutionary Innovation for Sustainable Engines program focuses on developing a range of advanced technologies aimed at dramatically improving engine efficiency and sustainability. These include composite fan blades, heat-resistant metal alloys, ceramic matrix composites, hybrid electric propulsion, and additive manufacturing, each contributing to a targeted 20% reduction in fuel burn and carbon dioxide emissions compared to today's most efficient engines. A key innovation is the CFM RISE engine's open fan architecture, which removes the traditional nacelle and core structure. This design enables more efficient air intake, a higher bypass ratio, and a smaller, lighter engine footprint, all while delivering improved propulsion efficiency. Safran has been advancing open rotor technology since 2008, successfully completing a series of tests on a demonstrator engine. These trials have demonstrated the design's potential to significantly reduce fuel consumption and emissions. Ground testing on an open air rig in Istres, southern France, confirmed that the open fan architecture enhances air intake efficiency while reducing the overall engine footprint. Safran continues to refine this technology through ongoing tests, aiming for commercial readiness by the mid-2030s. The CFM International LEAP-1A is a high-bypass turbofan engine developed for next-generation single-aisle commercial aircraft and serves as the first model in the LEAP engine family, succeeding in the widely used CFM56. Engineered for greater fuel efficiency and lower emissions, it incorporates advanced technologies such as a lean pre-mixed combustion system and a dual annular combustor, both designed to optimize performance while minimizing environmental impact. Building a LEAP engine is a highly intricate process that relies on a global network of suppliers and advanced manufacturing centers. To boost performance and durability, the engine integrates ceramic matrix composites, cutting-edge materials composed of ceramic fibers within a ceramic matrix. CMCHOs offer key advantages over traditional metals, including lighter weight, higher heat tolerance, and superior corrosion resistance, making them ideal for next-generation jet engine applications. U.S. and European cooperation is not limited to the production of aircraft and technology. It even extends to the bilateral cooperation between nations' militaries. The U.S. Dutch military relationship is built on decades of cooperation through NATO and joint operations. Both nations regularly participate in joint exercises like Defender Europe, Frisian Flag, and Falcon Autumn, enhancing interoperability in air, land, and cyber domains. These collaborations strengthen defense readiness and shared strategic interests. One notable example of U.S. Dutch military cooperation is a joint boat raid exercise conducted at Camp Lejeune, where U.S. Marines trained alongside Royal Netherlands Marines using Dutch Frisk fast-raiding interception and Special Forces craft. The training focused on amphibious assault tactics and maritime interdiction missions, emphasizing high-speed approaches, boarding procedures, and coastal combat operations. Conducted primarily on the agile Dutch Frisk, designed for swift insertion and extraction, the exercise enhanced interoperability and allowed both forces to share specialized tactics. U.S. Marines gained insight into Dutch maritime special operations. While Dutch troops adapted to Camp Lejeune's unique training terrain. This joint effort underscores the enduring military relationship between the United States and the Netherlands. The Dutch Frisk is a high-performance, tactical rib, rigid hull and floatable boat built for maritime special forces missions. It features a reinforced hull, shock-absorbing seats, advanced navigation, and multiple weapon mounts. Capable of speeds exceeding 40 knots and operating in adverse weather, it supports live fire training with FN Mag 7.62mm machine guns. Exercises include high-speed target engagement, ship-to-ship combat, coastal defense, and coordinated interdiction drills. Weapon integration ensures stability while firing at speed, and crews train for precision, target discrimination, and effective fire control in both day and night operations. Maritime special operations demand precision and seamless coordination, especially when combining air and sea assets. During Exercise Trident Juncture 2015, Dutch Special Forces demonstrated their expertise with complex helicopter-to-boat insertion drills. Operators from the Netherlands SOMTIG 20 frequently train with Belgium's Special Forces Group executing fast-rope descents onto frisks from helicopters such as the Spanish Sea King. Adverse weather conditions often add difficulty, challenging operators to transfer safely from aircraft to fast-moving vessels. These joint exercises, held at training hubs like Roda Naval Station, enhance interoperability between Allied maritime special operations units. This type of integrated training remains essential for sustaining readiness in high-risk scenarios, including counterterrorism at sea, vessel boarding operations, and coastal infiltration missions requiring rapid deployment of both helicopters and fast craft. Aircraft carriers are marvels of military power and technology. When we talk about aircraft carriers, we often refer to those of the U.S. Navy, but there are various nations with aircraft carriers. When comparing the world's aircraft carriers, only one comes close to matching the capabilities of those in the U.S. Navy, the French FS Charles de Gaulle. Like the Nimitz class, it employs the CATOBAR, Catapult-Assisted Takeoff but Arrested Recovery System, and is powered by a nuclear reactor. However, the Charles de Gaulle displaces less than half the tonnage and measures 860 feet in length compared to the 1,092 feet of a Nimitz-class carrier. It also carries fewer aircraft, primarily operating the Rafale M, France's carrier-based multi-role fighter. Despite its smaller size, its similar design allows for strong cooperation with U.S. forces. French Rafale M fighters regularly conduct cross-deck training on U.S. Navy carriers, highlighting close operational ties. With 6 NATO nations operating aircraft carriers, their combined maritime strength is considerable. The Charles de Gaulle, USS Harry S. Truman, CVN-75, and ITS Cavor can together form a formidable naval presence. Operating advanced aircraft like the Rafale M, FA-18 Super Hornet, and F-35, they provide air superiority, precision strike capabilities, and wide area surveillance. In tri-carrier operations, these vessels demonstrate effective multinational cooperation, enabling rapid deployment, strategic deterrence, and joint mission success, critical for maintaining stability in today's evolving global security landscape. Exercise Chesapeake marked a milestone in Allied naval aviation. It was the first time 350 French airmen from the embarked air group and the carrier Charles de Gaulle trained with the U.S. Navy on American soil. Named after the historic Battle of the Chesapeake, the exercise aimed to refine French pilot skills for carrier landings and takeoffs on U.S. platforms. This training strengthened tactical proficiency and deepened coordination with Allied forces. Globally, aircraft carriers, from Italy's Cavor and the UK's HMS Queen Elizabeth to the CATOBAR-enabled US and French carriers, continue to serve as the most powerful instruments of naval force projection. Autonomous vehicles are now at the epicenter of naval research, promising even more advanced capabilities. For the littoral environment, the NAVSEA has developed what they call CUSV, or the Common Unmanned Surface Vehicle. These autonomous boats are involved in the mine and countermine missions conducted by littoral combat ships. The Common Unmanned Surface Vehicle also plays an essential role in defending the U.S.'s most valuable littoral assets, like ports and harbors. Another cutting-edge advancement in naval technology is the integration of unmanned surface vessels, USVs, into the fleet. Platforms like the Ghost Fleet Overlord are fully autonomous, equipped with advanced sensors and onboard processing systems that allow them to interpret environmental data and respond independently. During missions, these USVs relay real-time intelligence to command centers ashore, enhancing situational awareness. THEMAR TAC-T 38 Devil Ray is another example, optimized for operations in shallow waters. Its high speed and maneuverability make it ideal for rapid response missions. Additionally, it can coordinate with manned ships, using data from other unmanned platforms to support integrated firepower. Technologies like these are reshaping naval warfare, expanding operational reach, and redefining what's possible in maritime defense. In a world where technological advancement and multinational cooperation define military power, the integration of cutting-edge propulsion systems, autonomous platforms, and joint operations has become essential. From revolutionary jet engine programs to seamless naval interoperability and unmanned maritime systems, these innovations are not only shaping the future of defense, they're ensuring readiness, resilience, and strategic dominance across every domain. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.